Okay, good day everyone. Justin Hanson here. I'm the Commercial Director for Digital Water Solutions. We also have Antonin from Devotech, as you can see. Today we're presenting on iDAS, the Infrastructure Design Automation Suite, and today we're going to focus on speeding up sewer network design. A little bit quickly about us, Digital Water Solutions. We're an Australian engineering consultant. We're an Autodesk Silver partner. We're the leading Autodesk water infrastructure reseller globally, and we're also an exclusive iDAS reseller for Australia and New Zealand. We also trade under the name Digital Asset Solutions when providing technology and solutions for non-water customers. Devotech, who are the creators of iDAS, they were established in 2005, and they're a multinational with offices in South Africa, Czech Republic, and New Zealand. The quick overview of iDAS, and obviously we'll go into it in a lot of detail shortly, but it's an automated modeling, design, and analysis solution. So it seamlessly integrates in with Civil 3D and accelerates the production of detailed drawings. So to go from concept design to detailed design to construction drawings in a fraction of the time. And today we're focusing on sewer, but it also provides benefit for roads, for water distribution, bulk water, stormwater networks, grading, and it's a very mature solution. So it's been developed for nearly 20 years and has over 2,000 active users globally, including many of the tier ones around the world. So iDAS is relatively new to Australia and New Zealand, and we are very excited and keen to promote it in this part of the world. But as I said, it's been used extensively around the world by the leading tier ones, and there's a few tier ones here in Australia and New Zealand that have adopted it and are starting to increase their usage of iDAS. I might pass over now to Antonin, who will give a little bit more detail on iDAS and then jump into a demonstration of iDAS for sewer network design.
Okay, thank you, Justin, for the introduction. And I will continue with the iDAS components. For those who didn't join the the previous webinar, I will briefly run through the iDAS components. iDAS consists from tools for analysis, design, reports, plan production, quantity takeoff, but not only that. iDAS also provides Civil 3D template with a matching CTB file, which is a plot style file that can be used for the plan production. iDAS also provides pipe network catalog that was developed for Australia and New Zealand market. We also provide training videos. I will discuss some of those components which I'm mentioning now a little bit more in detail. There's also a help file, very comprehensive help file with over 3,000 print screens. And while every software has a help file, our client sometimes says that our help file is actually helpful because we try to describe more in detail the workflows, the steps, and with the print screens and all that. And it doesn't only cover iDAS, it also covers Civil 3D topics. Some of the Civil 3D topics, not all of them, but quite a lot. And iDAS also provides sub-assemblies that can be used for road design. And now let me speak in more detail about some of those components. iDAS has over 150 multidisciplinary commands for points, surfaces, alignments, profiles, corridors, plant production, stormwater networks, sewer networks, water reticulation networks, bulk water pipeline, and other features. At the bottom of this slide, you can see print screens of some iDAS ribbons. Of course, these are not all the commands because there's a lot more and they wouldn't fit into this slide. But this is just to give you an idea that there is really a lot of commands. iDAS template was developed from AutoCAD ACAD ISO template because we didn't want to use any template that is available on the market provided by Autodesk. Those templates contain a lot of blocks and other objects that are not well named and they're not organized as we want. So we decided that we will develop a new template based on ACAD ISO, which is an empty template. And our template contains over 1,800 styles, and it supports various standards, but not fully all the standards, because there's a lot on the market. So, but if we feel like, yes, this is good and we can implement it, then we will implement it. And the same applies to client needs. If the client comes to us and he says, guys, I would like to have this in a template, and if we see that other clients will benefit from it as well, then we will develop it. We do also use consistent naming convention in our template. If you look on a print screen on the right hand side, you can see the surface style names. And quickly, if you see it for the first time, you have a good idea what that surface displays. We don't have any irrelevant objects or styles in a template. As I mentioned, we started from scratch. So we didn't want anything from any other template. We developed everything by ourselves. And since we use a proper naming convention, we know each block, where it is used and all that. iDAS template has a good performance because there are some templates on the market that are slow for whatever reason. I don't know why. However, iDAS has a good performance. If you compare, or iDAS template, if you compare our template with some other templates, you will see that our template performs well. And if there is a need, let's say you need some customization, let's say you like iDAS template, but you want some changes, we can help you with that. We also develop some tools that we can automate some of the changes if it is a lot of changes. So that's also an option. But you don't need to use iDAS template. If you want to work with iDAS, you can use any template and any pipe catalog. It really doesn't matter. And while I mentioned pipe catalog, for Australia and New Zealand, we developed the parts like structures and pipes. Here on the left-hand side, you can see the superstructures that we developed. And on the right-hand side, you can see the preview of the outfall structure with a manhole and some pipes. I will use those structures today during the demonstration, but there is a lot of pipes and structures that we develop for your region. And there's no point of having a good software if you don't know how to use it. So that's why we provide free of charge online training videos. There's over 215 videos with total length over 40 hours that you can use. And as you can see on the print screen below, the videos do have a timestamps, so you can quickly see what this video contains. You can go to a specific timestamp. If you are interested only in a specific topic, those videos can be shared with the colleagues. And our videos are workflow driven. What it means that we try to take you through beginning to the end, while with like some other training videos, they only cover the features or the tools, how they work. Well, we do that as well, but our main videos are workflow driven. And now let me go to demonstration, live demonstration in Civil 3D, and I'll show you how to do the super network design in Civil 3D. So let me go there. I will switch to Civil 3D. So now I'm in Civil 3D and I have a similar layout like I had the other time at the webinar, but here I have a Civil 3D surface. I do have lines and polylines for cadastral data, house boundaries, road edges, and pipe network. In this case, the pipe network is represented by polylines and lines. And I would like to convert all of them to a pipe network. We often use polylines and lines as a source objects, or mostly polylines, because they are easy to work with, and even the CAD person or CAD operator can sketch it for you. So that's what I'm doing or going to use right now. I will turn off the backdrop image because it is easier to see the objects. And let me convert the entire network to Civil 3D network. So I'm going to use a iDAS Sewer Wizard. And with Sewer Wizard, I can convert all the objects. Let me call or name the network. I will check the part list. I will select all the objects because I can filter them. And there's some, I can erase existing entities. And with a standard Civil 3D, you would need to convert each and every polyline to a pipe network, and then you would need to merge those networks into final networks. Luckily, you don't need to do that with iDAS. You can just select everything like I did. Then I need to specify the structures I want to use. I will scroll down slowly here so you can see the structure types or they call them structure families in Civil 3D, that we developed for sewer networks for Australia and New Zealand. And I will use a Humes manhole eccentric hole flanged. Then there are sizes for each family, so I will use the very first size, 1050. There are some other options here, but I don't want to do everything at once because I want to show you step by step, but there is an option to automate some of the steps with the wizard. Here, I need to specify the pipe type or pipe family. And again, let me scroll slowly down so you can see the pipe families that you can use for sewer network design. I'm slowly scrolling down. So there's really a lot. Again, you have also some generic types if you want to use them. And what I'm going to do right now, I will use the iPlex Nova Drain SN 450. And let me go next. Then I need to specify the label for structures. I will display name and label for pipes. And I will display the direction arrow. And the reason why I want to display direction arrow is that I want to verify that the pipes were drawn in a correct direction, or the polar lines. So let me zoom closer. So this is my network. As you can see, this is a standard Civil 3D pipe with the labels. But you can see that some arrows, they point in a wrong direction. Why is that happening? It is because the polar lines were drawn in an incorrect direction. If you don't draw a polar line in a flow direction, then this will be the result. With a standard Civil 3D, you have no tool to swap the pipe direction because you need to change the start and end structures. You may consider using the change flow direction command, which is in Civil 3D. Unfortunately, this command doesn't swap start and end structure. What it does, it changes, let me go to pipe properties, it changes the flow direction method from start to end to start. And that's not what you want to do because it might have some bad consequences further down. So you want to swap start and end structures. So as I mentioned, with a standard Civil 3D, unfortunately, you don't have a tool to do that. With iDAS, you can change the flow direction for the entire network at once. So let me do that. I can also swap the outfall structure. So I will use a Heinz Wingwall. And then let me click OK. I can also regrade the branch, but I will do it later on. And let me select the structure. And here it is. So I will align it with the pipe. I will show you that structure a bit later, but I want to show you that all the pipes, even if there was any other pipe somewhere here, if it was in an incorrect direction drawn, then it would be automatically adjusted and it would flow down to the outfall. So for the entire network, it is a matter of seconds to fix this problem. Let me just show you this structure. Let me go to Object Viewer. This is a outfall structure with the wing walls, which we developed in a part builder for your region. But of course, I can use here like a connect to existing, for example, or any other structure. Let me show you another command. If I look at those manholes here, you can see that they have a offset hole. And I want that hole to be on the roadside, not where there is an incoming or outgoing pipe. So I want to rotate those structures, but I don't want to rotate them manually. So I can rotate multiple structures at once. So let me select them. And if I know that they should use the same rotation, there are some options. How can I rotate structure relative to pipes and all that? So let me use here the settings. And as you can see, both are rotated now, and the lid is closer to the road. So I can rotate multiple structures at a time. Then I want to show you that with iDAS, we can swap multiple structures at once. With a standard Civil 3D, you either need to do it one by one, or you need to use some other little bit lengthy workflows to do that. With iDAS, you can just go to swap structures. Then you can select multiple structures. I will use a crossing window like this. And then you specify the family, you specify the size, you click OK, and it will swap to bigger size. As you can see, if you compare this size and that size, it's bigger. Now, if I go to properties, you will see that it is a bigger structure now, but let me not to go there because I want to save time for other topics. You can also swap conduits. Let me show you. You can swap multiple conduits at once. Again, it's very nice, very convenient, much quicker. So I selected some of the pipes. I will use a size 225. Let me click OK. And if I zoom in closer, you can see this pipe is 150. This one is 225. And I'm ready to create profile views. And I want to create profile views for the entire network. So I want the profile views to be located somewhere here. So I draw the rectangle. Again, with a standard Civil 3D, you would need to draw those profile views one by one. While with iDAS, I will create them for the entire network at once. And I went to Pipe Manager. Pipe Manager is a tool which we use for various things like adjusting the network, creating house connection, calculating bill of materials, assigning the values from as-built data. For example, here in plan, I can display the aerial image as well if I want to. But I don't want that for now, because I want clean drawing, so you can see better what I'm doing here. What I want to import the polar lines from the drawing so I can see better. And this is the rectangle which I draw for the profile views. So let me select the outfall structure, and then I can use a command in iDAS to create all the profile views. So let me specify the location where I want the profile views to be created. Then there is some settings. I'm not going to go in detail through those settings, but it offers a little bit more. And then I go to update Civil 3D drawing. And you can see I have the profile views here. I will delete the rectangle because I no longer need it. But what I don't like is that the profile views are overlapping. So I need to move them. With a standard Civil 3D, you would need to move the profile views one by one, and you don't want to do that. So I'm going to use the iDAS command modify views, which can be used for the section views as well as profile views. So let me select those profile views. And this command offers to align section views and profile views, to change the datum, change the height, change the space. So I want to change the space. There is also an option to specify horizontal, vertical, or grade. I can specify the location if I want to move them somewhere else, and I specify the gap between the profile views. And if I zoom out, I have a profile views nicely spreaded. And what I don't like is that the height differs. For the design profile views, it doesn't really matter, but for the production profile views, you want the height to be constant. So let me quickly do that. So I will select all these profile views. Then I want to change the height, and I have some other options here, but I think this will work well. And all the profile views do have the same height. If I check the profile view, you can see that the pipe network follows the surface, because when I converted polar lines to a pipe network, iDAS does that automatically. But I need to adjust the entire network. Again, with the standard Civil 3D, you need to go to each and every pipe, specify the slope, or maybe use the rules to grade the network. But with iDAS, we can regrade the entire network. Let me do that. I have some settings here. Let me specify the cover, let's say 1.2. There is some other settings, like you can specify the start slope, minimum slope, maximum slope, drop over structure, and all that. I will select the outfall structure, and then I will regrade the entire network at once. So currently iDAS is busy with that. And if I zoom closer, you can see the network was regraded. But as you can see, there are some issues because the structures do have a rims above surface. Why? Because they had a rim above surface. And this command, regrade network, regrades the pipe networks, the pipes itself. It doesn't adjust the rim elevations if it doesn't need to be adjusted, because maybe user wanted like that. But to adjust the rim elevations, you don't need to go one by one as you would do with a standard Civil 3D. You can simply go and adjust inverts, or use adjust inverts command that is used for the pipe inverts as well as structure rim elevations, some depth, and all that. So let me do it for the entire network. I will adjust the rim elevation to be on a surface. I can also adjust structure sump depth, and I can also specify whether I want a sump depth to be driven by depth or by elevation. What's the difference? If it is driven by depth, if you move the pipe up, then the structure will move up, excuse me. And if you have it by elevation, the elevation stay constant, so it is not related to the connected pipe. So I want to do it by depth for this case, and I click OK, and then I will adjust the entire network. And you can see the rim elevations are adjusted. And we do have some other tools for the adjustments. For example, I can specify, oh, here, because iDAS checks the cover at the beginning, at the end, there's something happening here. So I need deeper cover, and I want constant slope maybe up to this pipe somewhere here. So I want constant slope here. So I can use a grade pipes command. Again, I don't need to calculate what's the slope and assign it to those pipes, and I can rather do it automatically. And I can even specify the drop over structure. By the way, the drop over structure is measured at the structure center line, not between the walls. So that's something you need to consider. And it calculates the slope. I can also override the calculated slope. And then if I zoom in closer, you can see that there is a drop between the structure. So grade pipes command, very nice command. And let me zoom to another profile view. I will go somewhere here. And here you can see that I have a very steep pipe. If I check, it is 7.4%. And I need to probably add more structures because I want to have a little bit bigger drops to dissipate the energy and slow down the flow. So let me do that. Again, with a standard Civil 3D, you can't insert structures in profile views. You would need to go to plan and find out where to place those structures, because in some cases, it is more practical to place the structures in a plan. In some cases, you want to place them in a profile view. And I want to show you that because that's something you don't have with a standard Civil 3D. So let me use to iDAS command insert structure. Then I specify the network, the surface, the structure type, and I want to interpolate the depth. Okay, and I can specify the location. So I want the location to be somewhere here, there, and maybe those are the suitable locations where I have some changes in a surface. By the way, if I want to check where they are in plan, I can go to iDAS command find part. Then I can select structure that I want to display in plan. I can go there and I can click on a plan and it jumps to plan. I can click cancel. I can check whether the location is suitable. It looks okay. So I can go back to this command. It remembers the last structure. So I can simply just select and go back to profile view. It is very convenient to do it that way. By the way, we do also have a command to delete structure in a profile view, which is not possible with Civil 3D. If you delete structure in a profile view, it just removes it from the profile view, but it will remain in plan. While with iDAS, we can do that. We can even move the structure horizontally in profile view. So that helps if you want to adjust your structures in a profile view. But what I want to show you here, that we have other tools to grade the network. Let me go to Pipe Manager and I will show you that we have some other tools to regrade the networks. And those tools are very suitable for sewer networks. Let me not to import polar lines anymore. I don't need them. And I will turn off the polar lines. And then I go to Profile. I will scroll through profiles. I want to see the one I adjusted, so which is this one. By the way, in this profile, I have some other options. For example, I can go select multiple pipes. They are highlighted in a profile. And if I know that those pipes do have a fixed elevation, because that's the way they are and I can't modify them, I can log them. So I can go lock both ends and they will become gray in a profile. They have a padlock, so I know these pipes are locked. And if I want to adjust, let's say those pipes, let me select them. And I want to show you that we have some great options, and we can specify that we can have a fixed drop and we can calculate the slope. And let me show you how that works with a keyboard shortcut. I'm using keyboard shortcuts here, and you can see I can move the pipes up and down. I can move the start or end, as you can see. So this is very practical, very quick pipe network adjustment, because you can move it until you're happy. And if I change the settings here, great options. I want fixed slope and I want to calculate the drop. And as a slope, I want to use, let's say 1 in 30. And as a drop over structure, 0.05. And let me use that. And then I will select those paths again, and I will use that command. And as you can see that I can modify it like this. So until I'm happy. So I have a slope of 1 in 30 and I have a drop. Drop was calculated here. So I'm happy with this result. So I can go to Civil 3D, update Civil 3D drawing, and it will update my Civil 3D drawing, as you can see. So this is a very convenient way of designing the pipe network. Let me go to plan. What I want to do right now, I want to rename some pipes and structures. So let me use a standard Civil 3D for that. I go to rename network paths. I will select very first structure and the last for this branch. I will do the branch 1. And then it says rename network. Yes, I want branch 1 point starting number 1, and then the pipe 1 point starting number 1, and then I want to rename existing parts. Okay. For the last structure, which is outfall, let me go to structure properties and I will name it out as a outfall. Okay. And then if I come in here, you see I have a pipe network alignments for each and every branch, and this branch is called MH21 to MH28. I would like to rename all the alignments, so alignment name is equal to the start and end structures, because it's better if you want to use it for the plan production, if you want to use it for the profile view names and all that. So with standard Civil 3D, you would need to rename those alignments one by one. With iDAS, we have a command where you can do it automatically. So we can rename from structures, and we can rename the alignments as well as profile views. Let me click OK. I will select all of them, and then I hit enter. And if I zoom in closer and if I select this alignment, you can see this is alignment MH 1.1 to out. And if I select the other alignment, this is MH 32 to MH 1.4. So this is a very nice command. So I basically finished with the design. I can check the 3D view. Let me go to Prospector. I will select the network and I will go to Object Viewer. Before I do that, I will adjust the outfall structure, because since the outfall structure has a constant height, Civil 3D doesn't work that great with structures that do have a constant height. So let me go and select the network, and I go to Object Viewer, and I will zoom in so you can see the network. So this is the final network. But in many projects, what you need to do, if you have a sewer network, you need to prove that each and every house will be able to connect to the main pipeline. So I need to make sure that house connections will be able to connect to the main network. With a standard Civil 3D, you must create alignments for each and every stand and create profiles or create quick profiles from the polyline to see whether you can connect or not. With iDAS, we can automate this workflow. Let me convert cadastral data. I will select all the cadastral data to Civil 3D parcels. I'm going to use a parcel, create parcel from objects. And then I specify the style. I will use a residential. I can erase existing entities. I will turn off parcel area fill because I don't want to see the hatching. Okay, that looks a bit better. So these new yellow boundaries are parcel segments. They are either yellow or orange here. And now I'm ready to use iDAS to create sewer house connections. So let me go to Pipe Manager, and I will show you a few tools that we developed for this exercise. And it's busy opening. Okay, I will specify the site with the parcels, and then I can go to house connections. I will also go to house connection ribbon, because here I have various settings for the sewer house connection. I will not be able to go through all of them, but I will show you some of these features. And let me select all the parcels and let me create private sewer and house connections, and you will see what this command does. It's almost done. And for example, now the parcel 1 is selected. By the way, the numbering comes from the parcels. You can renumber the stands if you want to. So that's standard Civil 3D, so I'm not covering that. But what I want to show you that there is a private sewer line and house connection line. So there is a long section, private sewer line and house connection line. And let me select that parcel here. And it calculates the difference between the main pipeline and the house connection line. Based on a difference, it assigns type, let's say type 1, 2, 3, 4. The type can be specified by you under the connection types, where you can specify the minimum and maximum depth. And then you have some other values that you can display here. You can also export the grid to Excel if you want it for the report. And if you're not sure what these values mean, you can go to house connection details. And here you can see each and every parameter and see what it means. And let me go back to plan. And let me scroll to this side a bit. If the house connection tab, if it says pipe above house connection, so there's a problem and you need to fix it somehow. So how to fix that? There are two options. You can either modify house connection, or three options: modify house connection location, modify the private sewer line, or you can adjust the main pipeline. So let me show you. If you want to adjust the main pipeline, if I come in here, let me select the long section that might look a bit better. Maybe, so for example, I want to see, for example, this one. This one has a house connections here. So let me show you what you can do. So you can basically use the same tools like I used before to adjust the pipe. So I will just simply use a keyboard shortcut and I will move them a little bit down, for example, like that. I go a little bit deeper here, but you can use these tools. You can log them if you are happy with the outcome. You can log them. Again, I should go deeper here, but I think you got the idea how you can do it if you need to adjust the pipe. And once you do it, you can just simply select or recalculate the house connections. They will update the values, and so it's recalculating, okay, and it updates the values and you get a new result. And if you still have a problem, then you need to do something else about it. And I want to show you the other options you have here. For example, I will select the parcel 22, and let's say I don't want to run along the border. By the way, if I go to house connection, there's an option to specify the distance from border. I want to cross the parcel. So let me change the settings here. And then I will recalculate this parcel. Let me select the parcel 22. And I will go and add private sewer and house connections. And that will recalculate the house connection. And it creates a new profile, as you can see. And let me check the parcel 14. In this case, I don't want the house connection to be here. I want it in a corner. Again, I have a tool here where I can move house connection. I can specify a new location, and it automatically recalculates. And if I'm not happy with the line the way it is, I can modify it as well. Let me show you how can I do that. I can go back to Civil 3D. I clicked on Update, and that will create those objects in Civil 3D. You will see they will appear in plan. And the private sewer lines are represented by polylines. And if I zoom in closer, I have a polyline for private sewer line. I have a structure for house connection. I have a polyline for the house connection line. Then I can simply just select this polyline. I can say I want something like this. I want to add a vertex and maybe something like that. So this is my private sewer line. And let me open Pipe Manager again, and I will show you that the profile will be updated in a Pipe Manager. So basically I can check whether it's going to work or not. And let me go to house connections, and I will select parcel 14, and you can see this is updated profile view. If I want, I can display those profile or those house connections in a profile views, in a Civil 3D profile views. Let me add the house connections to profile views. I will select the tab. I will select a different tab. I will use an iPlex. I will use a different class because I want to use a 100 millimeters pipe. Then I will select style for the house connection. and I want to create paths only, and let me click OK. And that will create new network for the house connections, and it will project those house connections to profile views. Let me go to Home, and I will update the Civil 3D, and let me zoom to profile view, and you can see those little dots, or not dots, the pipes, and those are house connections. And if you want to, you can add the labels, because these are normal Civil 3D pipes. So I'm going to add labels, and then I will add the entire network in profile, and I will label pipes with the names, and I don't want to label any structures or crossing pipes. And then I will add a label, and the label or the pipe name is equal to the SC as a sewer connection, and 33, which is a parcel number. So if you use a correct parcel number, you know exactly where you have a problem here. And so this is briefly about the house connections. And let me show you some other tools. Some clients require that you display the values in a profile views every 20 meters and at the structures. Civil 3D doesn't have a tools to do it in an easy way, but with iDAS we have some tools to do that. First of all, I want to import band set with the values every 20 meters, and I will import that band set to multiple profile views, because with standard Civil 3D you need to go one by one. If you have 50 branches, you don't want to do it. So I will show you how to import band sets to multiple profile views at once, and this is a very useful tool. And I can specify the style for the profile view style as well as profile view band set. So you can also change the profile view style, but that's easy with a standard Civil 3D as well. And let me click OK. Now it updated the profile views. Let me zoom in closer, and you can see that something is not right here. The values do not look correct. It is because I need to specify the profile 1 and profile 2 in a profile view bands. And I need to create those profiles. So I need to create profiles from pipes. With a standard Civil 3D, you can't do that. You can do it manually. But with iDAS, we have a tool to create profiles from pipes for the sewer network. Okay. Then I specify the profile for invert and trench. I will use a depth 0.15 meters. Okay. And then I select the profile view. I specify the style for the pipe invert, and I specify the style for pipe trench. Then I click OK, and it creates those two profiles. As you can see, I made a mistake here. I didn't adjust the pipe network there, so that's why it goes up. But you know, it's very easy to modify. And then I can assign, or I can use those profiles to profile view bands. So if the profile view band name is written with the capital letters, then I know I need to pay attention to that style, because I need to set profile 1 and profile 2. And style itself tells me what to set as a profile 1 and profile 2. So this can be an inspiration for your template, for example, because I don't need to remember anything. I just come in here, I see capital letters, profile 1 invert, let me go there, and profile 2 NGL. And again, I go like that, invert NGL. Then the next one is an invert invert. So it's fairly quick, invert, invert, invert NGL, and then there is an invert trench, invert trench, and finally there is a trench and NGL. And that's it. And then I click OK. And now the long section looks perfect. I have a values every 20 meters. You can see 0, 20, 40, 60, as well as the values at the structures. But in Australia and New Zealand, they often display the profile views from the low point to high point. And as you can see, my profile view is drawn other way around. How can you fix it? Luckily with iDAS, we can reverse alignment direction. With standard Civil 3D, you can do that as well, but you can only reverse alignments. You can't reverse profiles, neither part network profiles nor the road profiles. You can't, simply there's no tool for that. And if you reverse alignments with Civil 3D, you can only reverse one alignment at a time, which you don't want to do again. So with iDAS, we have a command where we can reverse multiple alignments. So let me select everything. And I can also reverse profiles. You see, it's asking, do you want to reverse profiles? Yes, I want. And let me hit enter here, you get some warning, because of course, if you have a super elevation defined, for example, for the roads, that will have an impact. And if I zoom in closer now, you can see my profiles are from the low point to high point, and the profiles are reversed as well. So everything is perfect. So this is briefly about the sewer network design, house connections, and some tools related to profile views. And I will hand it over to Justin.
Yeah, thanks very much, everyone. Do we have any questions before we finish up? It doesn't look like any questions at the moment.
I checked the chat. It looks like there's no question.
Okay, no worries. Yeah, so yeah, thanks, Anton. From a typical return on investment for the iDAS product, it's quite a cheap product. You can purchase it as a subscription license or as a perpetual license. But for typically around $4,000 a year for a subscription license, Australian dollars, and depending on the nature of the projects that you're doing, we've seen around the world civil designers saving 30 to 60% of their time, or even more. And there you can see there on the screen, we've got a basic example of if you save 20% of your time using the iDAS to speed up the development of those drawings, then the ROI is very, very good, and pays for itself very quickly in a few months. But as I said, we're typically seeing ROI is much higher than that, and much better return on investment, and much bigger savings. What we're doing is we've set up a user group in Australia, meeting on Tuesday afternoon. So happy to pass on the details to anyone who's interested to come along and join. No cost, of course. We've got users from different organisations on Tuesday afternoons. We're also very pleased as we're introducing iDAS largely to this part of the world. It's used by a few large consultants here in Australia and New Zealand. But we are able to offer trial licenses of iDAS, so you can give it a go. You can come along to the user meetings, watch the tutorials and videos, and get all that proper help, as Anton talked about. And so just contact myself if you want any interest in a trial license for the product, and also any pricing information. All right, well, thank you again, Anton, and thank you to everyone for making the time to join. We'll also paste in after this session the link to watch the last webinar on water reticulation design in iDAS. I'll paste that into the chat here if anyone who missed that is interested in watching it. And thank you, and have a great day, and please be in touch if you're interested in a trial license or pricing. Thank you. Goodbye.
Okay, thank you, everybody.
Thank you.
Bye-bye.